Interactive surfaces are now common in everyday life. They allow users to walk up and use them with no instruction. However, current methods for providing tactile feedback require the user to cover up the visual content by touching the display or attach devices to their hands. We present UltraHaptics, a system that provides mid-air haptic feedback and requires no contact with either tools, attachments, or the surface itself. UltraHaptics uses a phased array of ultrasound transducers to create tactile focal points in mid-air. The array is driven by a stack of 5 driver boards, which receive emission patterns from a PC. The user's hands are tracked by a leap motion controller, and the haptic feedback is projected through an acoustically transparent display directly onto the user's bare hands. There are 4 steps to our unique focusing method. First, we define a large volume around the transducer array, within which we will model the ultrasound field. Then, we position positive control points where we want to form focal points. These tell the system to generate the highest intensity ultrasound possible at these locations. They are then surrounded with null control points. These have the opposite effect, telling the system to generate the lowest intensity ultrasound at these locations. Finally, the phase delay and amplitude are calculated for each transducer in the array to create an acoustic field that matches the control points. This simulation illustrates the acoustic field as we move up from the transducer array. Color represents phase, and brightness represents intensity. At a height of 20 centimeters, a focal point is formed. Above, the ultrasound defocuses once more. Similarly, this simulation shows 5 discrete focal points being formed at the same time. By varying the tactile properties of focal points, such as the frequency, they can be made to feel different from each other. In this scenario, a tactile information layer is created above the display. By moving their hand over the map, the user can feel the population density of a city. The frequency of a focal point represents the density in that area. Here, focal points are created above elements of a music player interface. This allows a user to locate themselves on the interface without looking. Tapping the focal point above the button starts and stops the music. The focal point above the volume slider can be grabbed. At this point, it pulses to inform the user that the system has recognized their grasp. The focal point can then be slid up and down to change the volume. These are just a few of the applications that become possible with the UltraHaptics system.